Welcome to the July 13th or 12th, depending on where you are, CNCF XDS Envoy Conformance planning and then touch-up meeting. And I'll be your host today, Hippie Hacker. But we've got some teams, the team of II meeting with the team from Envoy to go over some documents today. Zach, did you want to share those pieces and walk through that, or did you want me to?
Sure, yeah. It was shared in the, I'll throw it into the chat now, basically the design document that's open in the II XDS test harness repo. So
Beautiful.
Shared there, and if you wanted to share it on the screen, that'd be cool, but yeah, just seeking feedback for it.
So it might be a good idea to just sort of walk through this. That's the best way to, unfortunately, that's the best way to make sure that everyone actually has time to review it in detail, is to, force them all into the same room and make sure we get it done.
Here we are.
I did absolutely intend to review this before this meeting, and of course it did not happen. So
we all have lots of things on the plate, and do appreciate you taking time to go through this today with us. Zach, would you like me to walk through it, or would you like to? I've got it shared, and I can walk.
Sure. Yeah.
Check in with you.
Yeah, I think that might be easier practically, and then I can add clarifying comments as needed.
Sounds lovely. So I have read through this a couple of times, but I'm also going to come through it as if I'm reading it for the first time as a group. So this overall is the design document for how we're going to have this first 0.5. And there's some context and scope initially, then an overview, and then some definitions of things. A lot of that is we kind of link out this thing that's already defined in the statement of work, so we don't have to rewrite those things again. Some detailed design parts and some alternatives we can consider. And we felt that this document is it ties together all the other pieces of the statement of work, so that we're clear on how they all fit together. It will change over time, but I'm going to go ahead and go up the context of scope. It extends what's already there. We didn't rewrite what's in the statement of work, is what it basically says. In addition to what's there, we wanted to have an extensible case syntax that focused on behavior. Ideally, and this is why this next part of writing new tests without writing code, within the Kubernetes conformance, the idea of describing a behavior without specifying how we test it was something that we developed a different pattern for by writing super elaborate tickets that described the behavior. There was no gherkin. It was bringing those individual issues, tickets, with some example Go code to say, this is what we found that this is what we need to test, and how should we test it, and getting buy-off by the group before we wrote the test, because previously we would just start writing tests and everybody would say, no, that's not the right way to do it. And so it helps to separate out the people who are in the know of how things should behave from the people who are writing the underlying test. So approving behaviors and approving the way we test those behaviors.
So is it, I guess I'm not sure where this requirement comes from, right? I'm not sure that, like in this space, for the most part, the behavior that we're testing in the test, whether it's described like in English or in code, you can't really write that test without understanding like how the XDS protocol works and what it is that you're testing, right?
It's not without understanding how it works. It's without going in and writing an implementation specific thing at the description level. Hence the use of, here is the general message we're going to send. And here is the general thing we're going to accept. And that's with the matching between our underlying way we test with the way it's written in Gherkin.
Yeah, I guess it's not clear to me what we gain with this level of abstraction. Like, I don't necessarily object to it, but I'm just not sure it's actually a goal, right? Like, I think it would be fine. Like I've seen a lot of, end-to-end test frameworks that, have a bunch of utility functions that do all the steps of setup, and you can reuse those in multiple tests, and like that works fine. I don't necessarily think that we need to abstract away from that. Like I said, I don't object to doing so, but I don't think we have any requirement to do that.
Okay. I'm thinking about that for a bit because I want it in the way that we've written tests. A lot of what we've spent our time doing is trying to, and with the other places I've written tests with, is to get the definition of the behavior there. And what I hear you saying is that it's not important to have that delineation between the description of the behavior and the underlying implementation of the test, as far as you're concerned. Is that accurate? Or am I not hearing you?
No, I don't think that's entirely what I'm saying, right? What I'm saying is that like either way, you are providing an interface to write new tests. That interface may be English prose that you then, have some pattern matching to convert to something else, or it may be that something else directly. But either way, you have the same, atomic units of what you can express there. Right? Like for example, start with these resources loaded into the target, right? That's an atomic, piece of functionality that we're providing that will be used in a bunch of tests, right? Send this message, wait for this message to be received, right? There are a bunch of atomic pieces that you can then put together in any order that you want in any given test, right? But I think that there's no requirement to like those atomic units you can provide an API for, and you can say, okay, you just write a test as a piece of code that calls these atomic things, and that does it. I don't think that means that you have to expose all the details of what happens inside those atomic pieces. But I also don't necessarily see any value of having the interface to those atomic pieces be English instead of code. Does that make sense?
Yeah. So far we have chosen to go this route, and this is the first pushback on it. It would be quite difficult to try to go through and separate it. If you don't have a strong opinion for us to continue down that route, I'd prefer to keep going with the gherkin and the way we're headed.
So to be clear, I'm not objecting to doing it this way. I'm saying it's not a goal. So to list it as a goal, I think, is misleading.
Fair.
Right? That is an implementation choice that we've made. It's not a requirement.
All right. We'll take note of that, Zach, and we can move that to another location. Part of this was to have the case syntax behaviors, and we're focusing on the context and scope of defining this. What is the test case syntax? And so the syntax itself, the reason we kind of put that is that the syntax itself is gherkin. It is this DSL that we're working with. And so the syntax of that behavior is the form that we're saying, and this was asked for in the statement of work, what is the test case syntax? And so tying it together, this may be a side artifact of our choice of syntax, that we end up writing things more in this other descriptive language without writing new code. So not a goal, but an artifact of our chosen path. The framework being easy to contribute to, trying to make sure that it's easy to onboard new people in the way to create new matchers or to create new handlers for that. And that we don't have to predefine everything, that we can kind of go a new direction as required. Those three things being the primary goals beyond what we saw in the statement of works. Yes, they are things that we added, but we wanted to make sure that beyond that we agreed on these for clarity. And thank you, Mark, for noting that it's not a goal, but a side journey, the side effect of our choices. Some things we did not want to do was to write a new test case language, hence the choice of this particular one. We did not want to include tests that are specific to Envoy so that we can target all different implementations of XDS. And we're not going to write all known test cases. We're just going to write the ones that you directly assign. Any thoughts so far over the goals and non-goals? It's kind of our first section. The next part is the overview of it all. This is a collection. The test suite itself is a collection of behavior-driven tests, BDD. A test runner implements those tests as they're defined in code and runs them against the target. And the adapter spec, because we had some issues early on about what does that adapter spec look like, and now we've got a lot of clarity that that is a .proto implemented in the target, so that a runner can set the state. And use the runner as a language agnostic, that they would run against their XDS server, whether it's CS with their conformant or not. Again, we have to have that .proto defined and running prior to us running the test. After running it, the team would have an XML file. And there's some things that we're talking about here of why that's there, is when we get to the end result of somebody wants to be a conformant thing. Within the CNCF, we have a CNCF/K8S-conformance repository. And that repo, there's a folder for each release. And every vendor can submit their results as a folder underneath that with a product.yaml and their logs, particularly their JUnit based, because that's the standard that CI people use apparently for the results of their logs. And we have some automation already in place so that when we define here's the list of things that must pass, the bot can verify, yes, you have passed all of those things, so that somebody on the Envoy XDS or the API shepherds, whoever we set, maybe it's the CNCF employee, says you have actually submitted all these things. People can disagree with you by running their own test and submitting a, hey, they didn't actually pass. So that's why that XML with the complete results is there as part of our flow. The test cases, we try to do it different, separate from the implementation, as we said, using Gherkin testing language. It allows consistency to review for the API shepherds and others to see the scenarios and how they're used and articulated, so they're easier to read, and reuse those steps to minimize the amount of code needed to write new ones. Ideally, in one of, in a meeting, talk about that we could write new behaviors without writing any code, just writing another of these .feature files. That's the overview. Any questions or thoughts there?
Sounds really good.
Some concepts and definitions to kind of extend beyond what is there inside of the statement of work is these tests are written to support BDD, and BDD is a way of communicating a common language between the people who are the stakeholders and the people who are writing the test. And that's part of that division I was talking about around making sure that the API shepherds, being the stakeholders in this case, have something to review before we go forth and write the test to say, yes, this is a really good definition of done. Please make sure this is so, even if we don't have the matchers yet, because to go and write that work usually is a bit more intensive, and it allows a quick list. Yes, we approve. Please make sure these things are so. If you want to go deeper into that, there's a whole intro to BDD. Feel welcome to follow that along. We won't do that on this call. In practice, you can read it near language to describe at a high level all of the conformant features of XDS, almost like a set of it's a documentation of what you expect from XDS without having to be deeply into the code at that high level. These features then map to test implementation using that regex mapping as we go through those steps to test whether the target adequately fulfills all the things that the API shepherds have requested of a conformant XDS implementation. The core part of that is the series of steps and having this agreed upon syntax of what it means when we say these words, given some long thing, what those steps are, to map to their corresponding functions. Once we find the patterns, we can reuse those existing ones and allow people to write. Again, a side effect of this approach, allowing people to write new tests without having to write code or without having underlying knowledge of the code itself. Cucumber is a formalization of the behavior-driven development concepts and the testing grammar. Specifically, it uses a syntax called Gherkin to specify the given, when, and then matching in such a way that it can be mapped by many different underlying test frameworks. Currently, we're using GoDog, but we could just as easily swap out and use something in Python or choose if we need to switch the underlying implementation out while still holding true to the definition of conformance. Gherkin is the testing and language spec used by Cucumber, and it looks something like this: a feature line that says something about the feature overall. How do we buy vegetables in this case? And then multiple scenarios defining what we can do with vegetables. In this case, if you buy vegetables, there are less. And it's after each scenario, usually giving a given, when, and then, given a starting point, when we make some changes, then the conformance thing is at the bottom. Must have this step. Notably, there's not a whole lot of keywords. It's a small set that you map at the beginning of each testable function. And they're organized around this model of scenarios that have steps within features. You could have all of them in one file. You tend to have one feature per file that ends in .feature. And they're already color syntax code highlighted on GitHub and in your editors and everywhere else. It's a proper defining language. Any questions so far?
Yeah, so you said that scenarios are basically steps.
Scenarios, yes, that's true.
Describe non-sequential use cases, kind of scenarios that.
Can we walk through some of those?
So the question
I think
Sorry, go ahead.
There's a bit of a lag. I'm going to wait for you because, and when you're done, let me know when I can go.
Okay, so my question is whether we can use scenarios for non-sequential use cases. I'm done.
I'd like to look at what those might look like, because part of the non-sequential part is describing them in a match. And so given, it's always in any type of state checking, given the starting point for a non-sequential thing, when we initiate the non-sequential thing, then eventually we reach an end state where we can verify that the non-sequential stuff has happened and we're going to close it down. It's the begin. There's in going through, if you wouldn't mind describing one of those non-sequential steps, and we can talk about that. But as far as the general flow of how we match that into the underlying functionality, that's where we match this given the starting state. When we initiate change, then there's an endpoint.
Okay, so I'll give a short example, which is in non-ADS use cases, you can have multiple streams for a specific type, let's say EDS, and you can receive, you can request, let's say, 2 EDS messages or 2 EDS resources and receive them in different orders.
Mm-hmm.
So that's one of the cases. And
I think.
sure
Adi, can you give an example of like why?
Are we limiting ourselves by using this?
Sorry, I think I was talking over there a little bit, Adi. Sorry, I thought you were done, but I guess you weren't. I'm sorry, the lag cut in there. What I was going to ask is the case of multiple streams for the same resource type to the same server? Is that something that we need to test? Like, I mean, it seems like what we're testing is the properties of an individual XDS stream, right? The XDS protocol doesn't really define anything of what happens in one stream in relation to what happens in another stream. It only defines what happens in one stream. So it's not clear to me that that's a case that we actually need to cover here.
Conceptually, I agree with you. The question is whether we want to test races and stuff like that that can happen. And if we want to cover these kinds of tests, I'm not sure. Just putting it out there. If Gherkin and Cucumber and you know everything is can do that, I'm all for it.
Really, Gherkin itself doesn't accomplish anything other than describing our test at a high level, and then we map it to an underlying test implementation. It could be as simple as saying, given a scenario, given a start state where we're going to initiate multiple streams. When we perform a particular action that, and it could read very similar to that, when we perform an action that could create a race condition, then the race condition doesn't result in a negative thing, it results in what we were looking for. And as verbose as that is, you just map that to the underlying implementation. We can crank it back as much as possible to get it in the definition, but it's important to capture the intention of the test more so than the implementation details at that top level, if that makes sense.
Yeah, I would say that we're going to be having a trade-off with particular tests in which the basic format of starting condition, something happens, then there is a result. That something happens could be broad enough to not be sequential, but that means that the implementation of it has to have a lot more logic underneath it that is like opaque when looking at the natural language test itself. So the natural language test has a benefit of saying, you know, when you have these multiple streams coming in and all the resources are returned, or all the correct resources are returned, or what have you. Like, it's not specifying the order in which it's supposed to happen or how it looks. That does then become the responsibility of the implementation of that particular scenario, though, which might make that implementation complex.
I see. Thank you.
While I don't think that we're going to need to test multiple streams as a specific example, I do wonder, I mean, I think the question of race conditions is an interesting one in the sense that, you know, there are, the place where edge cases really, where race conditions really come up as edge cases in the protocol is like within a given stream, if like something that the client sends goes out before the client sees a response that the server has already sent at the point at which the client sends the message, right? Or vice versa, right? And so it's not clear to me how something like that would be expressed in this natural language form, right? How do you, how would you say that? Let me just ask, how would you express something like that?
I'm thinking for a moment. Zach, feel free to chime in.
Same, yeah.
If I were to write out something where I'm looking to see if something has been sent before, as you're sending it, you're going to have, I think one of the underlying concepts that we've mapped underneath is the concept of being able to look at that stream and send and receive from it. That's the highest level that we've gotten to right now. The abstraction of having multiple, like checking it to see what's there, because one thing that we haven't done yet, but that we will likely end up doing, is that through the duration of that stream, being able to go backwards and forwards from the point of where you're catching to look backwards, because it's a stream, right? And the events that have populated through in that time to match those. So given our current point, was there a message before here that was received that matches what we're trying to send at that time? So they want to be given this thing when we're about to send this message, ensuring that we haven't received it and we haven't received it before would be that quick check into our history of the stream. Oh wait, this is a race condition, or It'd be specific to how we would catch the race, but something like that. But
Yeah,
it's more about underlying mechanisms, how we catch it and map it up.
Yeah, I think maybe my concern is sort of, in order to actually run that test, you have to have some way of triggering the race. And I'm not sure how you would express that in this language. I don't want to get too bogged down in this specific example. I think, I'd like to continue going through the doc. You guys have done some good work writing this stuff, and I want to make sure we cover it. But I do want to follow up on this. And in particular, I'm thinking, I mean, from something you said earlier, it seems like you're wanting us to provide you a full list of scenarios, and I do think we need that list. And I think my inclination, just based on what we've heard so far, is we probably need to actually write up that list and make sure that it's comprehensive before we sort of finalize this, just because I think it's hard, at least for me, to evaluate whether the framework described in this design actually does everything we need without knowing what all those scenarios are, right? And so I think we're going to need to do the work of writing that up. But anyway, I want to let you continue, and I want to follow up on that separately.
Excellent.
And just one kind of final thought on that, like at a very high level, the answer, I think, to your question would be, it would be in the initial given statement. But that means that initial given statement, it's like setting up a scenario, but that setup is going to be increasingly complex. And so the thing that we might find, like, which is exactly why the figuring out all the test cases is a good idea, is it might hit a point in which the natural language becomes unreadable because of the gnarliness of the given state we're trying to express.
Yeah, I think that's kind of what I was groping for. That is sort of my concern there. But yeah, we can write up the list of scenarios and go from there. Anyway, I do want to let you guys continue. You've done good work here, and I want to see the rest of this.
I might summarize it. Given that test with the gnarly setup, and then it continues on, like, there's more to that story. Gherkin features, highest level. All right, so we're going to go through features. A behavior of the described system at the highest level most often is multiple scenarios that should possibly, that's the feature, and then multiple scenarios in one file, I think. But in total, give you an idea of a full description of the intended behavior that we would like to be part of every XDS server. For example, subscriptions might be a feature of the XDS protocol that are described for multiple scenarios, like subscribing, unsubscribing, subscribing, then resubscribing, and a bunch of different scenarios within the feature of subscriptions. Practically, this means that there's a whole collection of feature files, which each feature being a collection of these scenarios, and each scenario being a sequence of given, when, then steps. The scenarios themselves, kind of at this at the next level, are clear, simple, self-contained steps that are about an aspect of a feature. They are the heart of the cucumber and our testing suite, and are the closest analogy to a test. And it's structured as given starting state. When we mix, put it all in the bowl and hit the blend, then we have some lovely results that can be observed. Our scenarios are meant to be declarative and not a line-by-line description of how the test operates. Each line is in the scenario is called a step. And so underlying in the code, we have step matchers that match those given and when and then and steps. Steps themselves are written in a Gherkin syntax followed by some natural language. They can include dynamic variables and code blocks. For example, a table of values to go through, do all of this combinational matrix of things. If it's written cleanly, the step is we can use it for multiple scenarios. So when we start seeing patterns, that's when we want to rewrite a really good matcher that says, in this example, giving a server with a starting state of this YAML, there you go, would be matched to a test function that eats the YAML and shoves it across XDS. This means that you could have another scenario that also has a starting state, different YAML, same underlying function, no having to rewrite any code. I think we've covered that pretty well. Right now, we're using Godog, but there are tens of different languages that have Gherkin libraries to create test suites. And those languages look through all of these .feature files and map them in some way. And that's that mapping of matching those regular expressions of the feature steps, scenarios, and features all the way through to our underlying test framework that uses those feature files and the Golang library. The design, the detailed design, oops, and I clicked on something. It closely matches the original diagram in the statement of work, because I think it was pretty clear that we've added a little bit on the results with the JUnit, as I mentioned earlier. Our test binary is invoked with a simple configuration that needs that target and its adapter. So two different things that are two gRPC endpoints. The suite starts up an instance of our test runner and iterates over the collection of feature files. Each of the, it has a matching function to find for each of those steps to find the underlying Go code, which can do anything Go code can do. It's just this nice matching that we have. The test function utilizes the target adapter implementation so that we can set state and communicates directly to via XDS as well, and passes along stream state. So we store the stream state step to step via our runner so that our steps can look forward and backward across what's happened with the stream. The results are output to a JUnit or for further study, or like I was saying, for eventually certification. The crucial aspects of implemented in this design is that it's clean and consistent for our test so that we have a strong but flexible runner. That is our architecture. Any questions on the architecture?
Do you have a sense of how complicated the adapter is, or how simple it is?
It's described a little bit later on in the document, but it is simple. It's meant to be simple. So there should probably only be like at max like 5 services, but it's set state, update state is the like intended simplicity.
Okay.
I think you mean 5 methods, not 5 services, right?
Correct. Yeah. Or what in terms of the protobuf, the 5 RPCs or whatever.
Yeah, that's methods. Yeah.
Okay. Yeah.
There's the way the protobuf works is like there's one RPC service and it has multiple methods in it. I think you've got one service and 5 methods, not 5 different services here.
Exactly. Yeah.
And so basically the target needs to have an interface with the adapter to take in whatever the adapter got from the runner, right?
The gRPC
correct, yeah.
proto that we'll go through later
Okay.
is what the runner is communicating to say, please adapter, configure your target with these things so that we can start communicating over directly to the target to do validation.
Okay.
Because the XDS protocol itself doesn't have a way to please configure yourself.
Right. Okay. Thank you.
So the test case format in the repository itself is going to look something like this. Within the test suite, there will be a features folder. And inside that features folder, there will be multiple .feature files with different subscriptions, warming, and a bunch of other overall features. There'll be an internal folder with a parser and a runner, the main.go, which I haven't figured out yet, but I'm hoping that we can result in a self-contained binary. I'm not sure of its dependency on actually having the .feature files local to disk. My hope is that we can find some way to bootstrap this into a single Go binary that you download that will support just having an environment variable, however we want to configure it to point to those two gRPC endpoints. And then there's the steps, and the steps themselves are how we map those feature files. Sometimes we're not going to have reusable code, and we'll need to write some Golang to match those together. I believe that there's another file somewhere where we'll map those functions in those steps to the feature files. I'm going to scroll down a little bit just so that this is all on the page. Most importantly, for the test writer, the tests are specified as these .feature files and are implemented using a combination of the common, make sure we see the folder still, implementation of common steps and feature specific steps that are implemented in the runner. Hopefully, when there's a new feature, I'd like at least, it's like a reasonable goal, and whether it's a goal or not, hopefully a side effect is that we can reuse our existing scenario steps. This would reduce the volume of new code being written, allowed for contributions from more people who know XDS well, but we don't need to deep dive into Golang into the details of our implementation. Let's give an example of that. Let's say in the future, some new XDS feature is introduced, and we need to make sure it's part of conformance. For simplicity's sake, let's call it jump roping. A test writer wants to implement a new test in a PR to be merged into our test suite. In this example, the test writer is proficient in Golang. To start, they'd write up a new features file at features/jumprope.feature. It would describe jump roping features at several different levels, 1,000 feet, and illustrated with a set of scenarios for each aspect of that. The scenarios would contain steps pulled from the common library, such as setting the state, passing on the messages, validating response. In addition, there are some aspects that are not covered. It's going to need something new. So these new steps that are not matching inside of common would be placed into the steps jumprope.go file. These new steps would need to be added to the matching in main.go so that they're listed as what words map to this go function. The order of placement is not important, as the steps are mapped to scenarios via regular expression. Their PR would include changes to these three files: the creation of jumprope.go, the creation, I think it's a jumprope.features. I get to fix that in the update. Features/jumprope.feature, steps/jumprope.go, and the mapping in main.go. Later on, nuances are found with new jump rope and needing their own test. As a test writer without Golang proficiency, they read through jumprope.feature and the documentation of the common steps, and they write a new set of scenarios built on existing steps. This new PR with changes are only inside of, again, I think that's features/jumprope.feature. Any questions over our thoughts on the test case format? Because it does span, primarily we're trying to focus on the feature files, but this is how it all ties together in the test case format overall. Beautiful. Now we have to run that stuff. So this is the runner. All of the steps inside of our steps folder are test functions implemented as Go methods inside of our runner struct. The runner holds state that is meant to be passed along from step to step. An example runner that we're working with right now is the client config for pointing to our two different types of gRPC endpoints. The runners has a struct pointing to two client configs, the first one being the adapter and the target XDS service. Right now we have this CDS, which is our cluster discovery service struct, to have the stream. And note, Mark and Adi, that this is for a single stream currently. We can change this. This is internal to our test. And we have our list of responses we have received thus far for us being able to look back and see what's been here at that moment in time without having to touch the string. Before a scenario, the runner would connect to the target and adapter via gRPC. It will fail if it can't do that. it would store these connections to be accessed by each of the steps later in the scenarios. Similarly, a particular step to invoke a discovery response is stored in the runner and then validated in the following step by using the responses. The hook is run after a scenario to maintain the adapter and target connections, but cleans out any other state. And this is where we're going to get into the adapter protocol and how do you reset that state in the next steps. Any thoughts or questions on the runner?
When you say that after the hook is run, we clear the target connection, do you mean the connection or the stream?
Probably the stream. Zach, can you clarify?
It would be the stream, yeah.
Yeah. My
right.
apologies. Thank you for that. It's the
So,
first time
so
we've had
you are
eyes
actually
on this.
so you are actually maintaining one XDS stream to the target across all of the scenarios then.
It would be one stream across the steps of a scenario, not necessarily across scenarios. And so there's like 3 levels of grouping or whatever. So a feature is made up of multiple scenarios. Scenarios are made up of multiple steps. And in between scenarios, it likely you would be starting a new stream because it's testing some new concept. But it would all be grouped around a larger abstract notion that is the feature.
So I understand the relationship between features, scenarios, and steps. I guess I still just want to be concrete. At what layer, which of those layers is a stream associated with? Is a stream to the target associated with a scenario or with a feature?
A stream is associated with a scenario, and the connection would be with the feature. I think that this can be clarified better. Yeah.
Okay. Yeah, it would be good to clarify that in the doc, but the way you've described that just now sounds perfect.
Do we expect these different scenarios to run concurrently? Or it depends on how the target and adapter are integrated.
Could you repeat the first part of your question? Do you expect?
Oh, sorry. Do we expect the different scenarios to be run concurrently or sequentially?
I would say that the scenario should be designed to not require, they should be isolated from one another in terms of like what is being described, so that they could be run out of sequence, or like there is no specified sequence and it could be run concurrently. We didn't have it as like a requirement that they would be run concurrently. But just in terms of like proper design, a scenario should not require state setup in a previous scenario. They shouldn't have to know of one another.
I think I agree with what you just said, Zach. I do think, though, in this case, given the semantics of the adapter API, where I believe we said they're it's set state, right? So it's basically setting the entire state for the target. I think that means that the different scenarios actually cannot be run concurrently because each one may wipe out all of the state of the target.
We had talked about this on a prior call, and I think we agreed for 0.5 that there wasn't the correct level of isolation, so we don't clobber other tests, and that there might be features later similar to Kubernetes namespaces. And also it's creating and deciding whether it's okay. In Kubernetes, how we saw this was tagging particular tests as serial. And for the entire suite, you would need to run those serial tests. But there weren't very many, there were very few. And because they needed to be run in isolation because they destroyed nodes or something pretty wild. But we also had others that we labeled I forgot the other label off the top of my head. But that should allow us to have the teardown. So we have this idea of namespacing, and so everything is done within a namespace, and we delete the namespace outside of the testing framework to make sure that it's wiped, and Kubernetes deletes all of the objects inside of that. If there was a similar way to ensure no collision, another way is to just create a name string in front of it, and we arbitrarily create this string that says XDS-conformance -foo, or random string that is isolating it. In absence of something similar to a namespace, you just use a prefix instead of a namespace. But I don't know enough about how XDS works, if that would work later, but I don't think we need to tackle that now.
Yeah, I think it wouldn't. I mean, as you're right, we did discuss this previously, and I think what we had said was we would be able to do the thing in parallel if we change the adapter proto to be, instead of here's your complete state for the server, it would have to be like here's the individual resources to add or remove or update.
Absolutely. Right? Yep.
And it would depend on whether or not individual targets that we want to test for conformance would be able to handle that or not. Yeah. So we'll just have to see. But it's fine to leave this for future work, I think.
The last couple of parts here is the adapter protocol itself. It is a gRPC API, and it is defined in the test harness repo. The intention here is to allow us to set the required state for each test to run cleanly in isolation. The scope is meant to be very, very simple and limited. We just want to have a few things. One of them is set state to fully reset the target, currently without namespacing or isolation. So, or it can update state when the scenario is stateful. Example, we want to track the chain of various versions tracked across each state. The spec itself, the adapter API is specified within as a protobuf. It's the responsibility of people who would like conformance to implement that adapter for us to connect to. Basic version of where we're at now is clickable on this repo. We can follow through if you would like to look at that.
I think
sorry, go ahead, Zach.
Oh yeah, I was just gonna say, like, I think we've looked at it a few times. Like, there hasn't been any striking changes to that proto file.
Fair.
Yeah, I mean, right now it looks like that just has sort of set state. I think so. What would update state do differently from set state?
My thinking was the times, like, being able with the set state, being able to reset the versioning as well, whereas with update you would want to add a resource but have the version for that service updated as well for tests in which you are because one of the parts of the statement of work when it was saying testing the transport protocol was around versioning schemes. And so my imagining was to test versioning schemes, you wouldn't want to be resetting the state entirely. You'd want to have history associated with it.
Yeah, like, I don't know. So I guess one question here is what is the interface to different targets that we're going to want to test as far as versions go? Like, I don't know what Go control plane does, but Fusheng, you can jump in here, but I believe that what TD does is in the data that you feed it, there's no version number. You just give it a new config, and it creates the version based on the timestamp and the resource type. Is that right, Fusheng, or am I incorrect? And the version is actually part of the input data.
It's part of the input.
Oh, okay. Well, never mind then.
Yeah. Besides endpoints is dynamically generated by the control plane.
Yeah, I mean, endpoints. Yeah, so how does the version work for endpoints then, if it's not part of the input?
So it's TD just generate make sure it's atomically it's always increasing.
I see. Yeah, so this is going to be interesting. So it's we might need to flesh this out a little bit for like figuring out. We need to figure out, like, you know, do we need to expose all of these details of what the target does, or can we assume that the adapter implementation for that target will, you know, abstract away the details here, and what interface is that, you know, abstracted thing going to provide? But it's not clear to me that in all scenarios it will actually be possible for the adapter to take a version as input and impose that version on the target. So I think this part may need a little bit more thought, which I have another meeting in like 2 minutes, so we're not gonna be able to finish this today. But I think that's a follow-up item.
I think that this will evolve, and realize that anything we put into the adapter protocol becomes part of the conformance requirements, and everybody has to do. Just a quick wrap up. We did consider other things, and Mark went over these things earlier about what about these other ways. And but any testing syntax that was interplayed with a program language is kind of a non-starter, because we want to be able to read and discuss and onboard people quickly. This Gherkin provided the cleanest ways, the most established method across the industry for doing these BDD tests that I've seen that was non-language specific. Cucumber provides a lot of benefit. I'm just going to summarize for the simplicity. We chose GoDog, and it's well maintained without us having to necessarily tackle something new.
This looks really good. Yeah, I think you guys did a great job on this design. I think, you know, overall it looks really good. We've talked about the things we want to have some follow-up discussion on. The one AI, just I have to duck out, but the one AI that I want to make sure we get assigned on our end is writing up a list of scenarios that we want to test, because I think having that list will be really instructive to figure out whether there are any more holes in the design here. Fusheng, do you want to, since you're the only one here who's actually, you know, responsible for a management server, do you want to maybe take a stab at an initial list of test scenarios, and we can sort of iterate on that?
Sure. Yeah, I can try to get it started, and maybe you guys can help me to flesh out some of the details.
Yeah, sounds good. Why don't you start something? We can iterate a little on the doc, and then if we need a, you know, follow-up discussion, we can just, you know, on our end, you know, without having to drag in the II folks, we can sort of, you know, iterate on that, and then when we're happy with it, we can come back here and you know, go through it as a group and you know, make sure it looks reasonable.
So,
sound good?
By the way, we're only looking at the state of the world, right? Not Delta. For now.
Initially, I think that's true. I believe
Okay.
that's all that's in scope for 0.5. Is that right? Yeah.
No, it does both.
Oh, does it? Okay, great. All right. So yeah. So let's cover both then.
All right, we can scope it back. I'd love that, but
I mean, why don't we do this? I mean, if we'll say both are in scope for 0.5, but let's like start with state of the world, and then we can go to Delta.
Yeah.
My sense is we're not going to find that much in terms of like fundamentally different things that the framework's going to need to support in incremental that aren't there in state of the world.
I think we talked about being able to run the test twice, once with state of the world and once with the other, to see if there's any differences, just by changing the underlying implementation of how we validate the test.
Yeah, my suspicion is that there are going to be some test cases that are specific to incremental or specific to state of the world, but let's come up with this list of scenarios, and then we'll know for sure whether that's right or not.
Thank you, everybody, so much for your time. We'll see
All
you in a few
thank
weeks.
you. Yep. Bye.
Thanks all.
Thank you.
Thank you.